The sample being treated is dyed water. The sample on the left is the raw sample untreated. The sample on the right has just been through the EC machine and initial floc development can be seen. That will increase for the next half an hour and the floc will settle out. So a couple of minutes later you can see how quickly the floc's developed, and already it's settled out. That floc will continue to compact and the water will get progressively cleaner. I'm going to catch a third sample with the amps turned down, so less floc is generated to still get crystal clear water. Floc development's continued in the second sample. The sample on the right hand side is a fresh sample that's taken. The amps have been turned down from around 85 to 20, and that will generate less floc, and so what we'll see is less floc in the bottom of the sample jar after it's settled out. What can be seen here is that at 85 amps a lot of floc was generated and the water is crystal clear. At 20 amps a lot less floc was generated. There's less floc on the bottom of the sample, but clearly not quite enough aluminum was generated to clean up the sample. So as an optimization program, what we do now is run another sample at about 40 amps until we get the perfect balance between clean water without excess floc. Despite being taken 5 or 6 minutes after the 85 amp sample, you can see the 20 amp sample has generated its floc, settled out, and how much less floc there is, even though it hasn't been sitting as long. 40 amp sample, clean water, floc still compressing. I'd expect that to end up being below the 85 amp level and above the 20 amp level. Optimization in progress. So what we've demonstrated here is that amps control the amount of aluminum that is put off, and the amount of aluminum that's put off equates to the cleaning power and how much of the suspended solids you can remove. The raw water on the left, at 85 amps we were obviously over cleaning the water. It's crystal clear, but we generated more floc than was really necessary. At 20 amps a lot less floc was generated and really not quite enough to fully clean the sample. So at 40 amps you end up with a really good compromise, an optimized situation where there is more floc overall being generated than a 20 amp run. It is enough to clean up the water, so it's as clean as you need it, but you're not over generating floc and creating more floc than is necessary. Amps control cleaning power, and this is how you can optimize any water you want to treat. This is taken at a lower angle and is just to try to demonstrate the different levels of floc that can be seen in the 85 amp sample on the left. Highest amps, most floc. The 20 amp sample in the middle, lower amps, least floc, but wasn't able to adequately clean the water. And then the 40 amp sample on the far right, which got the water to a crystal clear state and only developed the amount of floc necessary to do that.